San Francisco is one of the most transportation-rich cities in the US.
San Francisco, as a city, is very forward-looking.
Well, San Francisco is the center of the technology world, where all these cars, light rail, pedestrians, scooters, bikes, where they all come together.
And San Francisco's always been looking at improving safety and improving the quality of mobility services in the city. So a proof of concept similar to an experiment. We're bringing together a lot of technology and with our partners we're testing at each stage to figure out how it all works.
Can you improve safety? Right? Can you improve the performance of public transit? And then lastly, can you reduce the greenhouse gas emissions?
We created a smart corridor where we connected 10 intersections in the Mission Bay neighborhood of San Francisco, where we monitor all traffic going through the intersections to ultimately improve the public transit speed.
And we really wanted to push the envelope to build something that can be repeated at scale.
The main challenge from my perspective as a project manager was the uncertainty around the outcome. Because this was a proof of concept, that means that we were doing something that had never really been done before.
So if we want to see if something works, San Francisco is the ultimate test bed.
So digital twins bring together a lot of data about a certain real-life situation and allow us to create some models about what's going on and how to make changes in the real world again.
If we can improve transportation, we're collecting real-time data, we're reacting to real-time data to see if we can improve transit while at the same time not negatively impacting these other modes. So the data aspect is very important and it's a very new thing that we're trying to do here.
From a technical standpoint, what we're doing is we're using LiDAR sensors to detect all traffic that's moving through a particular intersection. And software is able to identify the shape and size of each object.
Capturing the data is just part of the puzzle. So we're using their traffic flow engine to be able to analyze the data every 1 to 5 seconds and make a change back in the real world.
With the calculation we implemented, we call it near miss. Will two objects be at the same place within a second and a half, we said. So when it's so precise, you can walk to this intersection and you can see that crosswalk has a higher near miss than the other one. And you can take direct action. You increase the safety and experience for the people. Less near misses.
What excites me the most about the project is the impact that it can have on the users of the corridor to, at the end of the day, can save time by having smoother, shorter journeys.
The proof of concept's been fantastic, being able to show that it's worked as a solution. We've developed a digital twin in a box where we can take this to other cities around the world.
The most important outcome or indicator that this is working is that the waiting times for buses and light rail vehicles was reduced by over 20%, which is impressive.
I'd like to say that the project was a success through and through, and we are ready to tackle whatever comes next.
So Arcadis, we get the opportunity to make a difference in the world. So genuinely improving the quality of life. Things like this project where we're improving safety and transit for people in San Francisco. There's not a lot of places where you get the opportunity to make that difference.